Howdy, it's Papa. We've been talking about the Alleghenian orogeny, or mountain building event, that happened during the Pennsylvanian and Permian time periods. That would be about 330 million years ago, to about 300 million years ago, and that was the last big crashing event involved with the assembling of the supercontinent Pangaea. And I want to tell you about a place where you can go in Georgia that is the showcase of the Alleghenian orogeny erosion sediments, and that is Cloudland Canyon State Park. So let's find out where Cloudland Canyon State Park is and what is it. What's there that's cool? So here we go. This is not what I want to show you. Where is my picture? Hang on just a second. Here it is. Okay, this is a picture of the Cumberland Plateau. It's called the Allegheny Plateau up north, but here we call it the Cumberland Plateau. What am I talking about? See the yellow line here that's zigzagging down? Okay, to the right of this line, mostly the big patches of blue, is the Valley and Ridge Province to the east. And then west of that line is the Cumberland Plateau. Can you see the little red dot there? And you can see the drawing shows that the Cumberland Plateau is uplifted. It's about 800 feet straight up from the valley, this Macklemore Cove, which is part of the Valley and Ridge Province. Lookout Mountain, the top of Lookout Mountain is about 800 feet straight up, and that's the Cumberland Plateau. And you can see the red dot is Cloudland Canyon State Park. And I don't know if you can tell it, but Cloudland Canyon State Park is a canyon that cuts through the sandstone of the Cumberland Plateau going north. It's a north, opens up to the north, down into this blue, which is the valley. So that's where we're talking about going. And now I want to show you basically what the rocks of the Cloudland Canyon State Park look like. Got this drawing here. Okay. At the bottom of Lookout Mountain, which is where Cloudland Canyon State Park is, down in here. And I'm only showing you the west side of the cliffs. There's an east side over here that I haven't drawn, but down here at the bottom, it's limestone. This is limestone that was laid down in the foreland basin, the Alleghenian orogeny foreland basin during Mississippian time. So I call this Mississippian limestone. It has other names depending on where along the eastern seaboard you are, but I'm calling it Mississippian limestone. Limestone laid down in that foreland basin before the huge Alleghenian mountains that were pushed up when Africa crashed, before they began eroding onto the land. So that's the first thing you have. Then you know that if you stand at the beach anywhere, you're standing on sand. Okay, let's say it's a beach down near the tropics, and why the tropics? Because during this Alleghenian orogeny, the eastern United States was right on the equator, so it was in the tropics. So if you're standing on the beach in the tropics, and you just walk into the ocean, just say you can do that, and you keep your feet on the solid ground underneath the ocean instead of floating. After a long time, you're still walking on sand. After a while, though, the sand stops and you get into mud. And that's because the water that's coming down into the ocean via rivers can carry sand a little way before it loses its ability to carry it and it drops it. But it can carry mud a lot longer way because mud is smaller and lighter. Why does the ocean lose its ability to carry the sand? Because it's coming down through a restricted channel, a narrow channel, and so it has speed, velocity. But when it hits the ocean, the channel widens immensely almost infinitely into the ocean, so it loses its power. The sand drops out, but the mud stays there. So if you keep on walking, the sand will, under the ocean, the sand will give out, and then you'll be walking on mud. And then if you keep on walking, you'll get to the place where all the mud has already dropped out, and the water is crystal clear, perfect for sunlight to penetrate deeply, and shellfish and coral reefs can thrive in that kind of environment. And so you get this limey kind of mud buildup, and that limey mud turns into limestone. The mud turns into shale, and the sand turns into sandstone. Okay, so as the ocean rises, you start with your way out here in that 300-foot depth of water where the water's clear and clean, and these coral reefs and shell creatures thrive. But now these huge mountains are starting to erode into this ocean. So the land creeps out. That mud layer covers the limestone, the coral reefs, which have turned into limestone. So here's you get a layer of mud, which in this case is going to turn into shale. So you get a layer of shale. The ocean, the land is advanced, and you get shale. The land advances even more, and the beaches cover the shale. That's what this is. This is a sandstone cliff, one of the 3 sandstone cliffs that are at Cloudland Canyon State Park, and it represents the ocean first. Erosion occurred, and the mud layer covers the limestone. More erosion occurs. Sand beaches and sand deltas cover the mud. So you get sandstone cliffs. Sandstone cliff number 1. But then during this whole time, you were having these things called cyclotherms, and that's where glaciers formed, and the glaciers sucked up all the water in the world into ice sheets, and the ocean went down, and then the glaciers melted, and the oceans went up. So after the land encroached, the glacier melted, and the ocean came up and covered this sandstone, this sand layer, and a layer of mud was laid down. Then the ocean, the glaciers expanded again, and the ocean went down, and more erosion material came from these Alleghenian mountains, and so you get another sandstone cliff here, big sandstone cliff, maybe 100 feet tall. And then again the ocean rose again, and another layer of mud covers. And then again the ocean went down, and the sand advanced again, and you get this last layer of sandstone cliff. And then by this time, the erosion was so overpowering, and that it overdominated the mud flow and the rising of the oceans, and so coal swamps. This sand layer is like the beach and the sandy deltas, the barrier islands. But as the land eroded more, you got a coastal plain environment up here with these coastal plain swamps, and coal was formed. Okay, what else happened after that? Well, other layers may have formed on top of this that we don't know about, but they have been eroded away if they were ever formed. They're up in Pennsylvania, West Virginia, Kentucky. There are many coal layers, coal seams that are indicative of the coastal plain peat swamps that developed there, and that material did not erode away. Down here in Georgia, we were closer to much closer to the Foreland Basin. The rivers dumped right into the basin, and there wasn't enough of a braided river channel environment to create a lot of these coal swamps, and what there was has been eroded away. So we only get this one coal layer at the top, and that was the Durham coal mine. And you can go up there to the old Durham coal mine lands and collect Pennsylvania fern fossils in the waste material that they dug out of the mines. So that's how this Cloudland Canyon formed. Now let me go back to the book and go back to the other drawing that we were looking at. Okay, so you're in this Cloudland Canyon. You're on the top of this sandstone cliff, which would be up here. Oops. Would be like up in here. And there's a trail that goes down into this canyon. So you up on the sandstone cliffs, the soil is very poor, very sandy, very nutrient poor. And it's also acidic, so you get a lot of plants like American holly, like the sourwood tree, like the pines that can thrive in these nutrient poor, sandy kind of environments. But as you go down the trail that goes down into the canyon, you hit this limestone layer. Remember the limestone layer that's right here at the bottom. Things change immensely. Limestone makes everything, creates soils that make everything grow beautifully. And in this picture, you can the blue color is the limestone. So once the trail descends into this beautiful limestone layer, the wildflower display down there is incredibly rich. There's some really cool trees down there like umbrella magnolia that grow down there that they don't grow up on the top of the dry sandy top of Lookout Mountain. Another thing is this Cloudland Canyon itself points north. That means it's summertime. It's not exposed to the hot sun as much, so it's a cooler environment, and that encourages plants too. So it's the canyon itself, where the limestone is renowned for its beautiful wildflower display, and about April is a good time to go see that. And there's some unique plants down there that are specific to this kind of environment. If you go down, once you get into the limestone zone down there, at first you don't notice it because of all the pieces of rock that have broken off the cliffs and fallen down into the limestone. These cliffs have broken down and fallen into this limestone area, so you see a lot of the sandstone rocks there, but as you get down lower, you get into the limestone rock and the limestone soil. Notice that where you have sandstone cliffs, you have actual cliffs, because sandstone is resistant to erosion. Where you had the shale layers when the ocean came up, the shale is much less resistant to erosion, so you get these sloped areas, and here's where all the trees grow, on these sloped areas. Right in here and right in here. Okay, so that's the story of Cloudland Canyon State Park, a showcase of Pennsylvanian era rocks when the Allegheny orogeny was eroding into the Foreland Basin. Go up there and have a look. During COVID is a great time because maybe there won't be so many people up there, and it's outside jail, so you don't have to worry about social distancing too much. All right. Thumbs up to you guys, my rock buddies. I think about you all the time. Have a great day and have a great spring. Papa out.